Imagine staring at a puzzle that seems impossible at first glance. That's the magic moment when your brain starts firing on all cylinders, searching for patterns and connections that aren't immediately obvious. Let's explore why these mathematical mind-benders have captivated humans for centuries. Puzzles captivate us with their challenges and the joy of solving them. Math puzzles, in particular, combine logic, numbers, and patterns to engage both intellect and creativity. Beyond fun, math puzzles sharpen critical thinking and problem-solving skills. Picture this. A farmer stands at the edge of a river with an unusual group of travelers, a hungry wolf, a hungry goat, and a fresh cabbage. He needs to transport all three to the other side, but there's a catch. His small boat can only carry him and one passenger at a time. This might seem simple enough, but here's where it gets tricky. If left unsupervised, the wolf will devour the goat, and the goat will happily munch on the cabbage. It's a classic predator-prey plant chain that creates quite the logistical nightmare for our farmer. This puzzle, which has entertained minds for centuries, illustrates a fundamental principle of problem-solving. Sometimes going backwards is the key to moving forward. Let's watch how our clever farmer tackles this challenge. First, he takes the goat across. This is the only safe first move, as leaving the wolf with the goat or the goat with the cabbage would spell disaster. The wolf and cabbage remain safely on the original shore, as neither is interested in eating the other. Next, the farmer returns empty-handed and picks up the wolf. After dropping off the wolf on the far shore, he doesn't leave it with the goat. Instead, and here's the clever part, he brings the goat back to the starting side. Now he's free to transport the cabbage to the far shore, leaving it with the wolf. These two can safely coexist. Finally, he makes one last trip to collect the goat and ferry it across. 3 passengers safely transported, with no casualties along the way. It teaches us that sometimes the path to success isn't always a straight line. Sometimes you need to take a step backward to ultimately move forward.
Imagine you're camping with 3 friends when you come across an old rope bridge spanning a dark river. There's just one problem. You only have a single flashlight and it's getting dark. The bridge is rickety and narrow. Only 2 people can cross at a time, and everyone needs the flashlight to see where they're going. Here's where it gets interesting. Each person walks at a different speed. Let's call them quick, 1 minute to cross, swift, 2 minutes, steady, 5 minutes, and careful, 10 minutes. When 2 people cross together, they have to move at the slower person's pace. You might think the solution is obvious, just send people across in random pairs, but here's the catch. Someone has to bring the flashlight back each time. Let's solve this step by step. First, send Quick and Swift across together. Since Swift is slower, this takes 2 minutes. Now Quick comes back with the flashlight. That's another minute. Next comes the clever part. Send your 2 slowest members, steady and careful, across together. This takes 10 minutes, matching Careful's pace. Now Swift returns with the flashlight, 2 more minutes. Finally, Quick and Swift cross one last time, taking another 2 minutes. And there you have it. Everyone's across safely in just 17 minutes.
We all love a good brain teaser, and this classic puzzle is deceptively simple. Picture this. You're standing in a room with 3 ordinary light switches on the wall. In another room, completely out of sight, there's a single light bulb. Only one of these switches controls that bulb. Here's the catch: you can only check the bulb once. How do you figure out which switch is the right one? Your first instinct might be that this is impossible. After all, 3 switches and only 1 check seems like too little information. But this is where creative thinking comes in. The key insight is that a light bulb doesn't just have 2 states, on and off. It also has temperature. Here's the brilliant solution. Start by turning on switch number 1 and let it run for about 5 minutes. During this time, if switch 1 controls the bulb, it will heat up. Next, turn off switch 1 and immediately turn on switch 2. Now make your one and only visit to check the bulb. What you find tells you everything. If the bulb is currently lit, switch 2 is your answer. If the bulb is off but warm to the touch, switch 1 was your culprit. It had been heating the bulb earlier. And if the bulb is off and cold, process of elimination tells you it must be switch 3. This puzzle beautifully demonstrates how lateral thinking can solve seemingly impossible problems. It reminds us that the obvious solution isn't always the only solution. Sometimes the answer lies not in what we can see directly, but in understanding the secondary effects of our actions. What makes this puzzle so elegant is how it transforms a seemingly impossible three-way choice into a clear solution by using a property we often overlook: heat. It's a perfect example of how thinking outside the box can turn an unsolvable problem into a solvable one.
Have you ever wondered why tech companies ask weird puzzle questions in interviews? Well, today we're going to solve one of the most famous water jug puzzles, and trust me, it's more fascinating than it sounds. Imagine you're standing at a river with two jugs. One holds 5 liters and the other holds 3 liters. Your task is to measure exactly 4 liters of water. There are no markings on the jugs and you can't eyeball it. Sounds impossible, right? But there's a beautiful solution that demonstrates the power of logical thinking. Here's how we solve it. First, we fill the 5-liter jug completely. Now we have 5 liters of water to work with. Next, we carefully pour water from the 5-liter jug into the 3-liter jug until it's full. Since the 3-liter jug was empty, this leaves exactly 2 liters in our 5-liter jug. Now comes the clever part. We empty the 3-liter jug completely and pour our precious 2 liters from the 5-liter jug into the now empty 3-liter jug. Finally, we fill the 5-liter jug once again and carefully pour into the 3-liter jug, which already contains 2 liters. The 3-liter jug can only accept 1 more liter, leaving exactly 4 liters in our 5-liter jug. And there we have it. Through a series of precise pours, we've measured exactly 4 liters using only 2 jugs that couldn't measure 4 liters directly. This puzzle reminds us that sometimes the path to our goal isn't straightforward. We might need to take several steps back to move forward.
Imagine standing before a perfectly round birthday cake, beautifully frosted and waiting to be shared. But here's the challenge. You need to divide it into 8 equal pieces, and you can only make 3 cuts. Impossible? Not at all. Let's unlock this clever puzzle. Most people's first instinct is to slice the cake like a pizza, making cuts from the center outward. But that would require 7 cuts to get 8 pieces. We need to think differently, to think in 3 dimensions. Here's the elegant solution. Start by making 2 perpendicular cuts across the top of the cake, like drawing a plus sign. This creates 4 equal quarters, but we're not done. The magic happens with the 3rd and final cut. Instead of cutting downward again, we slice horizontally through the middle of the cake, parallel to the table. This single cut transforms our 4 pieces into 8 perfectly equal portions. This puzzle teaches us an important lesson. Sometimes the solution requires us to shift our perspective and think outside the box, or in this case, inside the cake.